I would like to welcome you all in the lecture series of power electronics. In this session, I'll be discussing one of the most important topic, that is TRIAC. TRIAC is a power electronic device. It is similar to SCR, but the construction is such a way that two SCRs are connected in anti-parallel. So that is the peculiarity of TRIAC. Also, it will allow bidirectional conduction. Okay, so in this video, we are going to discuss about what is TRIAC, symbol, then construction, operation, later advantage, disadvantage, ultimately applications. These are the major agenda of the presentation. First of all, I'll be talking about what do you mean by TRIAC. We'll have a brief discussion on TRIAC. So first we'll understand what is a TRIAC. A TRIAC is defined as a three-terminal AC switch, which is different from other SCR in the sense we can conduct in both the direction. Here, it is a three-terminal device. It allows bidirectional conduction. Also, we can turn on the TRIAC by providing the positive gate pulse or negative gate pulse so that TRIAC will conduct. So we can call it as TRIAC is a controlled device. It's a controlled device. So for how many layers are there? There are 4 layers. It performs bidirectional conduction. The maximum rating till 16 kilowatts that is available in the market. So have you ever seen TRIAC? Yes, in your fan regulator, you can see fan regulator. Okay, we have the fan regulator. Or also we can control the universal motor. We can control in mixer grinder and all, we can control the universal motor by using TRIAC. Okay. So the AC voltage controller, that's a major application, light dimmer. So there are so many applications of TRIAC. So it is more attractive. Also, the requirement of heat sink is less compared to individual SCR. That is another plus point. So how about the construction? Yes, before that I'll explain the symbol. So you can, the symbol will be exactly in this fashion. So we have 3 terminal, MT2, then MT1, then gate terminal. If they ask about the symbol, it is desirable to mark this particular diagram. So this is the circuit symbol. Now, how do you say that TRIAC is known as anti-parallel connection of SCR? Yes, of course. Please observe here. So we have SCR1 and we too have SCR2. How does it connect? Can you imagine? It's an anti-parallel connection. The anode of one SCR that is connected to cathode of another SCR. Similarly, cathode of SCR1 is connected to anode of SCR2. Like that, it is connected. Also, gate is also connected. Ultimately, we have only single gate terminal, then another main terminal 1 and main terminal 2. There are 3 terminals available. So this is the way how it is connected. So in the physical construction, we can mark like this. So PN junction. Okay, we have PN, then NPN. Okay. So like that, it is connected each other, and MT1 and M2 are the main terminal 1. We have the gate. Any manner we can represent. However, if anybody asked about the symbol of TRIAC, it is advisable to mark the third one. This is a circuit symbol. Rest of the things are also correct, but it is easy to represent the third method. Hope it is clear to everyone. Now, let me proceed further. So I'm going to explain the construction of TRIAC. How we can find out the construction, how it is made up of all the terminology we can find out. So first of all, we can see different layers. So you see, this is one layer, and N1 is one, N2 is one layer. So you can see this is one layer, layer number 1. So layer number 2, then we have another layer number 3, then layer number 4, ultimately layer number 5. Okay, then we have main terminal 2 and main terminal 1. Also, we have the gate terminal. This is the way how it is constructed. It is similar to SCR, but there is a difference in the layer. Number of layers will be different. That's all. Now we'll discuss the working. How does it work? Or characteristics of TRIAC. So you already know that it's a bidirectional device. Okay, it is a bidirectional device. Note the point, please. Also, it will work on first and third quadrant. First and third quadrant. Please observe here. This is your first quadrant, and we have the third quadrant. So, of course, the TRIAC is operated both first and second quadrant. How does it turn on? How it is going to turn on? First of all, if we increase the voltage, anode to cathode voltage, there is a very small amount of current that is going to be started, but the growth of current is very less. Immediately you need to provide the gate impulse. Okay, immediately if you provide the gate impulse, what you can do, at a particular point that is called as latching current, the SCR will completely turn on. If you want to like turn off SCR, what you can do, the latching current you have to reduce to below the holding current. The anode current should goes below the holding current. So that what I can say, SCR will be operating. Here we can say like MT2 greater than MT1. MT2 greater than MT1. At the first quadrant, this is a situation. Okay, MT2 greater than MT1. So how about the conduction? Conduction, anode current flows from MT2 to MT1. That is actually what exactly mentioned over there. That is the operation in the first quadrant. It is 100% similar to SCR only. Okay, so look at the first quadrant. Okay, you can mention about the VBO, forward breakover voltage. So immediately if you provide the gating signal, the device will be completely turned off. So if you want to turn off means you have to reduce the anode current below the holding current. Okay, please refer the videos of latching current and holding current in my previous session. It's very clearly explained. Let us move on to if MT1 is greater than MT2. So how about the current flow? Current flow will be from MT1 to MT2. So of course, we can say that this operation will be held in the negative direction. Therefore, we can say like operation will be at the third quadrant. Here, the voltage and current both are in the negative direction. However, we can say like if you maintain like MT1 high potential compared to MT2, of course, current flow from MT1 to MT2. So this is regarding forward breakover voltage. Breakover voltage in another direction. So if you provide the gating current, what is going to happen? Before that, it will directly turn on. Okay. So better go for like a gate triggering. So we are commonly using a gate triggering only. Okay. It is the best method. Gate triggering method. How to turn on TRIAC? We use gate triggering methods. So only the difference is it will operate in first and third quadrant, unlike your SCR. That is a major difference. I think it's clear to everybody. Kindly make a note of this operation. Okay, that is more than sufficient. So two cases you have to explain. If MT2 greater than MT1, the current flow will be taken from MT2 to MT1. So don't forget to provide the gating signal. That is mandatory. Whenever MT1, second case, MT1 greater than MT2, current flow will be always from MT1 to MT2. So again, the same condition, but the second condition, MT1 greater than MT2 will fall at third quadrant. Hope it is clear to everybody. Now let us discuss advantage, disadvantage, and applications. Yes, what are the advantages? It can be triggered by positive and negative polarity of gate pulses. For third quadrant, I can go for negative polarity. So it's up to you, positive or negative pulses. It requires only single heatsink of slightly larger size, whereas SCR of two heatsink is required separately. Suppose if I want to go for bidirectional conduction by using SCR separately I require a heatsink. That is not worth it. If you want to add more heatsink means it is economically not viable. It requires high fuse for the protection. Single fuse for the protection, unlike a separate SCR fusing. A safe breakdown in either direction is possible, but SCR protection should be given with a parallel diode. So these are the major peculiarity, advantages of TRIAC. Now let me talk about the major disadvantages of TRIAC. What are the major disadvantages? Just please make a note that there are not too much reliable compared to SCR. Reliability is poor compared to SCR because it is an anti-parallel connection of SCR. There are some other components which is present in TRIAC. So that is not economically viable as good as like SCR. It has dV by dt rating lower than SCR. Okay. So you might have studied about the dV by dt protection. We have to find out some other dV by dt protection. Lower ratings are available compared to SCR. We need to be careful about the triggering circuit as it can be triggered in both the directions. So that we have to very clear. So make sure that which triggering which condition you will be following, either first condition or the second condition. That you should be very much particular. Otherwise, the device will unwantedly turn on. It will be hampered your application. So decide how does polarity has to be maintained. That should be taken care into consideration. Now let us see some important applications. They used in major control circuits and high power lamp switching, also used in the AC power control. Okay, so these are the light dimmer. These are the various applications of TRIAC. TRIAC is nothing but triode for alternating current, TRIAC. Okay, so I hope you understood a little bit concept about the TRIAC. I referred the textbook, so many textbook I have referred, even textbook of Rashid I have referred and studied in detail. Let me know if you have any questions related to TRIAC, kindly let me know, because this is one of the most important question you can expect in the any form at any time in various type of examination. I wish you all the very best for your examination. Happy learning. Have a great day. Thank you so much for watching this video.